Welcome back to the Deep Dive. We're here again to really dig into those complex tech and security topics, cut through the noise, and hopefully give you the insights you need, especially you developers, PMs, analysts out there trying to keep up. And today we've got a really critical topic. It's right at that intersection of, amazing productivity boosts and frankly, some pretty big risks. We're calling this one Protecting Sensitive Data from Generative AI Tools. Because, let's face it, Gen AI, huge unlock, biggest in years.
Absolutely. But the security side, especially around data leaks, well, it's still playing catch up with how fast everyone's adopting these tools. And yeah, this is an episode of the Data Zen AI podcast. We're brought to you by the Data Zen community. Our whole mission really is to help you understand and use AI safely, effectively. So today we're diving into that maybe uncomfortable truth about how tools like ChatGPT, Copilot, Gemini, how they actually handle your data. Where does it go? We want you to walk away from this, not just with a sense of the risk, but with actual practical knowledge, things you could do to stop a data disaster before it happens.
Yeah, practical steps, not just fear.
Exactly. And just a quick reminder, this deep dive, like all our content, it's available in multiple languages. Find us on most popular podcast platforms. We want everyone everywhere to be able to learn this stuff.
Great point. So, our goal for you listening today is simple. When you're using these tools, maybe for debugging some code, maybe summarizing client notes, really sensitive stuff sometimes, you need to know where the dangers are, and crucially, how to put up the right guardrails. We're moving past the panic and into practical protection. Okay, let's unpack this. All right, so let's kick off with what seems to be a really common misunderstanding, maybe the fundamental one. This idea that Gen AI tools are like, disposable calculators.
Right.
You type something in, you get your answer out, and poof, the input, your sensitive data, it just disappears, feels temporary, private.
And that feeling, that's the danger zone. It feels ephemeral, but it's fundamentally misleading. Honestly, this calculator myth is probably driving the biggest chunk of security risk for companies right now. We have to correct it. So let's talk about the core risks, data retention, training data. It's not simple. First off, and this is the one most people kind of get now, many popular Gen AI apps, especially the free ones or the standard tiers, they log everything.
Everything.
Your prompts, the whole chat history, it's stored. And often that logged data, it gets used to train the next version of the public model. Which means your confidential info, maybe that bit of proprietary code you pasted, it could potentially influence future responses. Or worse, it could even get regurgitated verbatim for some other user down the line.
Okay, hold on. That leads directly to the big question I know our listeners have. Can AI models actually remember what we type? Like, really remember?
Yes. Emphatically, yes.
Right.
And that's where the term regurgitation is so important. It's a huge technical risk.
How does that happen, practically?
Well, think about it. If sensitive information, especially, unmasked data, structured data, if that gets into the massive training data set, the model learns patterns. It learns to reproduce stuff. So if another user later puts in a prompt that's, similar enough to your original input that contained the sensitive bit, the model might just spit that sensitive data right back out. It's not just a filtering problem on the output side. It's a failure of input hygiene. What went in during training wasn't clean.
Okay, that's worrying. And it's not just about future training, is it? The data is still logged somewhere, even if it's not immediately used for training.
Exactly right.
Yeah.
That brings us to the other risks. Risk number 2. The human element. That log data sits on the vendor servers. And guess what? Developers, internal reviewers, maybe safety teams at the vendor, they might be able to access it.
Even with NDAs and stuff.
Even with NDAs.
Yeah.
Still exposure to a third party. And risk number 3, which honestly for PMs tracking liability might be the scariest long term, is a future breach.
Right. The vendor gets hacked.
Precisely. And suddenly, terabytes of supposedly private conversations full of confidential data spill out onto the internet.
Okay, let's make this concrete. OpenAI is obviously the big example everyone looks at. Their standard policy, historically, was retaining chats indefinitely unless you actively deleted them.
The baseline, yeah. Relatively manageable, you'd think. But then there's this huge shift. Happened around June 2025, and it fundamentally changed the game for basically everyone not on a high-end enterprise plan. This is what we call the opt-out illusion.
The opt-out illusion. Okay, unpack that.
So you used to be able to go in your settings, find the privacy portal, and opt out of your data being used for training.
Right, I remember that setting.
Well, an update revealed that because of a court order, some new legal mandates, OpenAI is now required to keep all consumer content, indefinitely.
Wait, all content, regardless of whether I opted out of training, regardless of whether I hit delete?
Exactly, indefinitely. That opt-out setting, it only affects future training, potentially, does not affect this mandatory legal retention.
So if I've been carefully following the advice, regularly clear your chat history, that's now completely pointless for actual deletion.
It's cosmetic. It removes the chat from your view, your interface history, but behind the scenes. That data is immediately shunted into a separate system for legal retention.
Wow.
Think about the implications for organizations. If you're bound by GDPR's right to erasure for client data or some other regulation, you literally cannot guarantee deletion anymore just by clicking that button. The vendor is legally compelled to keep it.
That's a massive liability shift.
Wow.
Okay, what about those features specifically designed for privacy, like temporary chats? Weren't they meant to have zero retention?
That was the original idea, yes. But given how sweeping this legal mandate is described, covering all user content, it's highly likely those are compromised too.
So even temporary isn't temporary anymore?
It's safest to assume not, until the vendor provides a clear, verifiable, maybe technically backed guarantee otherwise. Assume that content is also being retained under this mandate. The original purpose is probably invalidated.
Okay, so this is feeling a bit bleak. If I'm a PM or a developer and I'm handling super sensitive IP client data, stuff that absolutely cannot be stored or used, what's the safe harbor? Is there one left?
There is one, but it's specific. The only truly guaranteed safe harbor mentioned in the sources we looked at is using specialized enterprise offerings, things that come with a contractual zero data retention agreement or a ZDR.
DDR, okay.
This is a strict, legally binding guarantee about data handling, and it only applies to specific high-tier accounts, ChatGPT Enterprise, ChatGPT Edu, and crucially, API customers who have explicitly negotiated and signed a ZDR agreement with the vendor.
So if I'm using the free version or Plus Pro, even the team accounts?
No ZDR by default. If you're on Free Plus Pro Team or using the standard API without that specific ZDR contract in place, your content falls under that indefinite legal retention mandate.
Making it basically unacceptable for most proprietary or regulated data.
Pretty much. That's the bottom line. Okay, so now that we understand the retention reality, we need to think bigger about what sensitive data actually means in this context. For our audience, devs, PMs, analysts, it's got to be more than just, PII, like names and addresses.
Right, it's about the company jewels.
Exactly. When you're talking to an AI, sensitive data is anything that could hurt your competitive edge, violate client trust, or breach some kind of fiduciary duty. So think broader. Financial records, sure, but also proprietary algorithms, customer databases, internal strategy docs, employee data, legal communications, project roadmaps, even details about your vendor relationships. Anything that gives you an advantage or exposes you or your clients, it all needs protection from that retention trap.
Okay, let's make this super practical then. Can we list out the specific types of data people should absolutely never share with these public-facing platforms, like a top 6 list of no-nos?
Good idea. Let's do the big 6.
Number 1, and probably the most relevant for many listeners, sensitive company data, the secret sauce.
This is top of the list for a reason. It's the company's core IP, the algorithms, the product designs, the strategic plans. And the temptation to use AI for efficiency here is huge.
Like debugging code.
Precisely. We keep bringing up the Samsung incident because it's the textbook example. An employee, trying to save time, pasted sensitive source code into ChatGPT for debugging help. Huge ouch. Led directly to a data exposure incident and an internal ban on the tool. It's not theoretical. It's happened. That's also why giants like Apple banned ChatGPT for certain teams working on sensitive projects. The risk. Loss of IP, loss of competitive advantage. Simple as that.
Okay. Number 2, creative works and intellectual property, IP. Maybe not code, but like my brilliant novel idea or a unique game mechanic.
Yeah, be really careful here.
Yeah.
Sharing original unpublished creative work, your next great novel outline, your unique game logic, character designs before it's protected or published. You risk losing exclusivity. Well, first, it's now sitting on a third-party server, subject to their retention policies. Second, there's that risk of model leakage or regurgitation we talked about. Your unique concept could surface in someone else's result.
Yikes.
And third, there are already legal battles brewing. Authors like Sarah Silverman, George R.R. Martin, they're suing AI companies, alleging their published copyrighted works were scraped and used for training without permission. So imagine putting unpublished work in there.
Okay, definitely avoid that. Number 3, financial information. This feels like common sense, but
You'd be surprised. Treat that chat input box like a public bulletin board. You wouldn't post your bank account number, your credit card details, your social security number on Reddit, right?
Hopefully not.
So don't put it in a chatbot prompt either.
Yeah.
Asking it to analyze detailed company financial spreadsheets. Even if you're just looking for general advice, that's effectively uploading sensitive data. Plus, there's the added risk of phishing fake AI sites designed just to steal this stuff. Fine for general budgeting tips, maybe, but never specific account numbers or balances.
Got it. Number 4, personal data. Name, address, phone number, mother's maiden name, the usual suspects.
All the classics. These are the building blocks for identity theft and fraud. Scammers piece together these little bits of info to impersonate people, breach accounts.
And developers might use real data for testing.
Big mistake. Always resist that temptation. Use synthetic data, fully anonymized data, never your own real details or anyone else's.
Number 5, usernames and passwords. Again, seems obvious, but convenience.
Convenience kills here. Pasting passwords into a chat history, maybe asking the bot to remember this for me, that's incredibly poor security practice.
Why specifically?
Because if that chat history gets breached, or if the vendor is legally compelled to hand over logs, your plain text credentials are right there, exposed.
So what's the alternative if you struggle with passwords?
Use a proper password manager, a secure encrypted vault designed for this, preferably with multi-factor authentication, not the AI chat window.
Right. Okay. And the final one, number 6. This one's a bit meta. ChatGPT chats themselves, the actual requests you make.
Yeah, this often gets missed. The content to your prompt is the data leak. And we know these systems aren't foolproof.
How so?
Well, there's that infamous bug where some ChatGPT users suddenly started seeing the chat histories of other users, a direct cross-user data leak.
Whoa.
And there's also evidence suggesting other platforms, like Google's Bard back in the day, actually indexed some user chats, making them potentially discoverable via search engines.
The takeaway. Nothing is truly private or perfectly segmented in these rapidly evolving systems. Don't assume your chat is siloed.
Okay, that list of don'ts is pretty clear. Now let's shift gears to the how. How does this sensitive data actually leak out in a real company setting? Which brings us back to that critical question for our listeners. Is it ever safe to use these AI tools on actual client data?
Outside of those very specific, contractually guaranteed ZDR enterprise setups we mentioned, the short, sharp answer is almost certainly no.
Why so definitive? Because the ways data leaks are often tied to, well, human nature. Convenience, lack of visibility, and the simple economics of free versus paid tools. Remember that stat?
Yeah.
Something like 64% of ChatGPT users are reportedly on the free tier.
Right.
And that free tier generally trains on user data by default.
Yeah.
You have to actively hunt down an opt-out setting, assuming it even fully works against retention anymore. Relying on every single employee to do that, that's not a strategy. It's wishful thinking.
And this leads us nicely into the problem of shadow AI. Sounds ominous.
It kind of is. Shadow AI is basically all those unapproved AI tools, browser plugins, little niche services that employees find and start using because they're quick and easy. They don't go through IT, they don't get vetted by security.
They just want to get the job done faster.
Exactly. But these tools are often security nightmares. They might lack basic encryption, they almost certainly log everything you feed them, including company secrets, and they haven't been through the rigorous security testing that major vendors, for all their faults, generally apply. Their back doors waiting to happen.
Is there a real-world example of this going wrong?
Oh, yeah. The OmniGPT hack is the poster child for shadow AI risks.
OmniGPT? What was that?
It was a third-party service, an aggregator. It offered this slick interface where you could access multiple AI models like ChatGPT and Claude all in one place. Super convenient, right?
Sounds useful, actually.
Until it got breached. Hackers got access to over 34 million chat records.
34 million?
Yep. Full conversation histories, user logins, embedded API keys people had put in there, even confidential files employees had uploaded financial data, customer lists, the works. And the worst part, many companies had no idea their employees were even using OmniGPT until the breach notification came out. All because staff chose convenience over the approved vetted tools.
That's terrifying. Okay, so shadow AI is one pathway. What about vulnerabilities within the approved Gen AI systems themselves, even if we avoid the dodgy plugins?
Yeah, there are still inherent risks. Two main technical failure points to watch. The first one is pretty straightforward. User input vulnerabilities.
Just pasting stuff in.
Exactly. An employee, under pressure, just copies and pastes a chunk of confidential code or a client list or sensitive meeting notes directly into the chat window for a quick summary or analysis. They think it's a private conversation.
But they're effectively uploading it to the vendor's potentially leaky infrastructure.
Precisely. The second is more subtle, more technical. Model output information disclosure, sometimes called cross-conversation contamination.
How does that work?
So even if a later user submits a perfectly clean, harmless prompt, the underlying model, because of how it was trained on potentially sensitive past data, might still leak information.
Leak information from other users' previous inputs.
Potentially, yes. An attacker could craft clever prompts, sometimes called inference attacks, that don't directly ask for sensitive data, but cause the model to piece together correlations or specific examples it learned during training, and inadvertently reveal details from someone else's session. It's exploiting the model's memory, essentially.
Okay, that sounds like a deep architectural challenge. And layered on top of all this, there's this growing geopolitical risk factor, right? Especially concerning where the data is hosted.
Absolutely critical point, especially for PMs and analysts dealing with compliance. Think GDPR, IPA, CCPA.
Where does geography come into it?
We're seeing more AI tools pop up that are hosted in specific countries. Think tools like DeepSeek, QuenChat, ErnieBot. Many are based in China.
And the significance of that is?
Local laws. In some jurisdictions, like China, the government has legal authority to compel companies to provide access to user data stored on servers within their borders. And that includes data from foreign businesses using those services.
So if my team uses one of these tools, maybe hosted in China, to process client records,
You could be in direct violation of data privacy regulations like GDPR, which has strict rules about data sovereignty and transferring data outside the EU, or IPA, with its rules on handling protected health information.
so using the wrong tool isn't just a security risk, it's a potential legal and compliance violation with massive fines. Exactly. DeepSeek's policy, for example, reportedly states user chats and documents are stored indefinitely on Chinese servers. Using that for sensitive EU climate data, that's a huge compliance failure waiting to happen. It moves beyond maybe we'll get breached to we are actively violating the law right now.
Okay, we've covered the theory, the risks, the sneaky ways data can get out. Now let's talk about when things go boom, real-world catastrophes. Because sometimes those low probability risks feel very real when controls are missing. This is where it gets really interesting, folks.
It really is. And these incidents drive home the point. We mentioned Samsung, already developer pastes code, another uploads meeting notes, boom, internal ban. Classic case of convenience trumping security, leading to immediate corporate pain.
Right. But let's dig into one that's maybe more technically complex and instructive for our developer and QA listeners. That massive Microsoft 38 terabyte exposure.
Yes, that was
Yeah.
colossal. And frankly, pretty embarrassing for Microsoft, given it came from their own AI research team.
What exactly happened there? 38 terabytes is an insane amount of data. It is. They were getting ready to publish an open source AI model repository on GitHub called Robust Models Transfer. To share the models, they needed to provide access to files stored in an Azure storage account.
Standard procedure, sounds like.
Should have been. But the way they provided access was fatally flawed. They used something called a Shared Access Signature Token, or SAS token.
Okay, what's a SAS token for those who don't live in Azure?
Think of it like a special temporary key embedded in a URL. It grants specific permissions to specific Azure storage resources for a specific time.
Yeah.
Very useful for controlled sharing, if configured correctly.
And Microsoft's wasn't.
Not even close. They made multiple critical errors. First, they accidentally posted the entire SAS token URL into a public GitHub repository. Anyone could find it.
Ouch.
Second, the token was wildly misconfigured. It had excessive permissions, including write and delete permissions, not just read. Third, it was scoped incorrectly. Instead of pointing just to the folder with the open source models, it granted access to the entire Azure storage account it lived in.
The entire account, with write-delete permissions, from a public link.
Yep, a trifecta of failure. It completely violated the principle of least privilege.
So what was actually exposed in those 38 terabytes? It wasn't just the models, presumably?
Far from it. The researchers found backups of 2 employees' entire workstations. Think personal files, system files, and critically, secrets, private keys, passwords, credentials, all sitting there.
Oh my God.
And over 30,000 internal Microsoft Teams messages from hundreds of employees were also in that storage account, exposed by the same token. Plus, because of those write permissions, there was a terrifying risk of supply chain attacks. An attacker could have potentially modified the AI models before others downloaded them.
That's staggering. What are the big lessons here for developers managing cloud stuff?
Well, the immediate fix was obviously revoking the token. But the lasting lessons: 1. Enforce least privilege ruthlessly, always. 2. Be incredibly strict about the scope and expiration dates on any sharing mechanism like SaaS tokens. 3. Security scanning needs to evolve. Automated secret scanning tools must be configured to specifically detect exposed and overly permissive SaaS tokens, not just typical API keys or passwords. It proved that even sophisticated AI work relies on getting basic cloud security right.
A harsh lesson. Okay, let's shift from corporate catastrophe to something more personal, but just as revealing about data permanence. That bizarre story about the Missouri student confession via ChatGPT.
Right. This one perfectly illustrates how non-ephemeral these chat logs really are, especially in the eyes of law enforcement.
What happened?
So a Missouri State University student allegedly went on a rampage, vandalized about 17 cars on campus. Bad move. But what he did immediately after is fascinating from our perspective.
He talked to ChatGPT.
He sure did. He pulled out his iPhone, opened ChatGPT, and essentially confessed everything.
What did he actually type? Do we know?
We do, from the police reports. His first prompt was, and I'm quoting here, the incredibly relatable, "How fucked am I, bro?"
Oh, wow. Seriously.
Seriously. Then he just unloaded, typed out detailed admissions, things like, "It felt dirty nice to fuck their hit up," typos, and all described his panic the whole event.
And the police found this.
Yep. They seized his iPhone, recovered the entire conversation log from the ChatGPT app. Those typo-filled, timestamp confessions, combined with location data from his phone, became compelling evidence against him.
So the takeaway isn't just don't confess crimes to chatbots.
Oh, that's good advice, too. The real takeaway for our audience is that law enforcement can and will retrieve these logs. They are treated as discoverable, time-stamped evidence. Putting sensitive company data, client secrets, or yes, criminal confessions into these platforms, you absolutely cannot rely on perceived privacy or the chat window disappearing to protect you from legal scrutiny or those data retention mandates we discussed. It's recorded.
Okay, we've seen the risks, the real-world consequences. It's clear that just banning AI isn't the answer that just drives usage underground into that dangerous shadow AI territory. So the only real path forward is building smart, effective guardrails. Which leads to the big question for organizations. How do enterprises prevent data leaks when using AI? What do the defenses look like?
Right. And the mindset has to shift completely. It's no longer about trusting employees to do the right thing. It's about implementing technical enforcement and automated controls.
Oh, you start.
You actually start before the AI-specific stuff. Get the fundamentals right. Robust infrastructure security, proper network segmentation, maybe isolating Gen AI tools in their own zone, strong endpoint protection on user devices, and a mature vulnerability management program. You can't build secure AI on a shaky foundation.
Basics first. Got it. Then what?
Then comes policy, but a policy that's enforceable. It's a cycle. Step 1, clearly define what data is absolutely off limits for any external AI tool unless it's on an approved ZDR platform. Be specific. Source code, PII, financial projections, client lists. Step 2, explicitly approve the safe tools. Maybe it's OpenAI Enterprise with ZDR, maybe Azure OpenAI, Gemini Advanced with the right settings. Step 3, and this is key, deploy technology to monitor and enforce that policy in real time. Block ban tools. Block sensitive data from going into approved tools if it violates policy.
Okay, let's get into those technical controls. These are crucial for the devs and security teams listening. We hear data loss prevention, DLP, mentioned a lot. What does DLP actually do in an LLM context? Is it just keyword blocking?
It's much more sophisticated than that now, or it needs to be. AI-aware DLP tools need to understand context and data types. They monitor the data flowing to the AI model's prompts, uploaded files, and also the data coming back in the model's responses.
How does it protect the input?
It uses pattern matching, maybe machine learning classifiers, to identify sensitive data types, PII, PHI, credit card numbers, source code snippets, custom company identifiers. When it detects something forbidden, it can take action. Block the prompt entirely, or automatically redact or mask the sensitive parts before letting the sanitized version proceed to the AI.
So it cleans the data on the way in.
Ideally, yes.
Right.
Or blocks it.
Yeah.
And it needs to watch the output, too. If the AI suddenly generates something that looks like a list of social security numbers, the DLP should flag or block that response before it reaches the user. It's about controlling both ends of the pipe.
Makes sense. Okay, next control. Hardening the inputs and outputs. You said treat every prompt as untrusted. What does that involve? Things like preventing prompt injection or jailbreaking.
Exactly. And it's important to know the difference. Prompt injection is when an attacker tries to sneak hidden instructions into the input, maybe inside a document the AI is asked to summarize. The goal is to make the AI ignore its original purpose and do something malicious instead, like leak its system prompt or previous conversation data.
Okay, hijacking the AI's instructions. What's jailbreaking then?
Jailbreaking is more about bypassing the AI's built-in safety filters, trying to trick the model into generating harmful, unethical, or forbidden content, like writing malware, giving instructions for illegal activities, things it's been trained not to do.
So how do you technically stop these?
You need layers. First, input validation using rule-based filters. Think regular expressions, regex, to catch known malicious patterns or sensitive data formats like SSMs, keyword blacklists for forbidden terms, but that's not enough on its own.
Why not?
Because attackers get clever. They use obfuscation, weird encodings, ways to bypass simple rules. So you need to combine rule-based filters with more advanced AI-driven anomaly detection that can spot unusual or suspicious prompt structures, even if they don't match a known bad pattern. Treat the input like you treat input to a web application. Sanitize, validate, assume it's hostile.
Layers of defense. Okay, what about encryption? Always a security fundamental.
Non-negotiable. You need strong encryption, like AES-256, applied across the entire life cycle. Data at rest, your training data sets, your logs, needs to be encrypted. Data in transit, when prompts and responses travel over the network to the API, must use TLS, obviously. And critically, data during processing.
During processing, how does that work?
This is where it gets more advanced. Ideally, you want protection, even while the data is being actively used by the model. End-to-end encryption for the whole pipeline is the goal.
You mentioned advanced concepts for super sensitive stuff. Could you briefly touch on confidential computing versus homomorphic encryption? When would you use each?
Sure, they offer different levels of protection and have different performance trade-offs. Confidential computing uses special hardware-secure enclaves, like Intel SGX or AMD SEV. These create a protected bubble inside the CPU where code and data can be processed, encrypted even while in memory. The operating system, the hypervisor, cloud provider admins, they can't see inside the enclave.
So it protects data during use with hardware help.
Exactly. It offers a pretty good balance of strong protection and reasonable performance. It's becoming more practical for securing sensitive AI workloads in production today.
And homomorphic encryption.
Homomorphic encryption, HE, is the theoretical holy grail. It's pure math. It allows you to perform computations directly on encrypted data without ever decrypting it. The results are encrypted, and only someone with the key can decrypt the final answer. Ultimate privacy.
Sounds amazing. What's the catch?
Performance. Massive performance overhead. Doing math on encrypted data is computationally very expensive. It can slow things down by orders of magnitude. So HE is really only viable today for very specific niche use cases where the absolute mathematical guarantee of privacy outweighs any speed concerns. Think maybe certain types of medical research or secure voting systems. Not generally practical for real-time chatbot interactions yet.
Good distinction. Okay, two more key areas, proactive testing and access control.
Absolutely. Role-based access control, RBAC, is fundamental. Just like with any system, users interacting with AI tools, especially via APIs, should only have the permissions necessary for their job. Define granular roles. Does this user need to fine-tune models? Do they need access to the raw logs? Probably not. Limit access based on role and necessity.
Makes sense. And testing. You said traditional red teaming isn't enough.
Right. LLMs introduce new attack surfaces. Standard penetration testing might miss things like sophisticated prompt injection or model inversion attacks. We need AI-specific offensive security. That's where continuous automated red teaming CART tools are emerging.
CARTs.
Yeah, these tools are designed to continuously probe your AI systems, simulating the kinds of attacks specific to AI, trying different prompt injections, attempting to leak training data, testing the model's safety boundaries. It's about finding those unique AI vulnerabilities automatically and constantly, not just once a year during a manual test. Think of it like automated security testing, specifically tailored for the weirdness of AI.
So constantly poking the bear to find weak spots.
Pretty much. And finally, underlying all the tech, especially for PMs, signing the checks. Vendor risk assessment. Don't just take the vendor's marketing claims at face value.
What should you scrutinize?
Dig deep. Verify their data handling policies. What are their actual security controls? Where geographically will your data be stored? What are the real retention periods, especially in light of those legal mandates? Get it all in the contract. Explicitly negotiate ZDR if you need it. Clarify liability, breach notification timelines. Due diligence is paramount. Trust, but verify, especially when it comes to vendor contracts. Hashtag outro.
Okay, wow. We've covered a huge amount of ground there, from the core risks to the nitty-gritty technical defenses. So what's the big takeaway for everyone listening, the developers, the PMs, the analysts?
I think for me, it's that Gen AI is undeniably powerful, a massive productivity boost.
Sure. But relying on trust or good intentions or just assuming the vendor has it covered, that's not a security strategy. It has to be about technical enforcement, clear policies, constant vigilance, and those ZDR contracts for anything truly sensitive. Assume indefinite retention unless proven otherwise in writing.
Couldn't agree more. And that leads me to maybe a final provocative thought for everyone to chew on. Given this major shift we discussed, the indefinite legal retention of consumer data, even stuff you thought you deleted, the entire focus, organizationally, has to shift.
Shift how?
It has to move away from trying to manage the data after it's already in the vendor system. That battle is getting harder, maybe impossible for consumer tiers. The only truly reliable security posture now is focusing intensely on preventing the sensitive data from being input in the first place.
Wow. So the war is won or lost at the prompt bot.
That's where the critical control point is now.
Yeah.
Block it before it ever leaves your environment.
A really powerful and actionable way to frame it. Excellent point to end on. Thank you so much for walking us through all this today. It's been incredibly insightful.
My pleasure. It's a critical conversation we all need to be having. Thanks for tuning in, everyone.
Absolutely. And if you found this deep dive valuable, please do subscribe. Spotify, Apple Podcasts, wherever you get your podcasts. That way, you won't miss our future explorations.
Yeah, and please share your feedback. Let us know what you thought or suggest other AI topics you're wrestling with. We want to cover what's relevant to you.
Definitely. And lastly, don't forget to check out datazen.top. That's the home of the Datazen community. You'll find more content there, meetups, articles, interviews, all sorts of good stuff.
Stay safe out there and keep learning.
We'll catch you on the next deep dive.